everyone and welcome back to another Universe Sandbox 2 video. Today we are going to be looking at the planet with the largest rings ever discovered. So this planet was discovered quite a while ago now actually, but anyways, I made a simulation quite a long time ago of it. This is probably when I first actually got the game, and this one takes a while to load because once you see these rings, you can't actually see them yet, but once you see these rings, you'll know why this simulation is going to be very, very laggy and slow. So let's turn the time down, and now voila. So as you can see here, those rings are absolutely huge. So we're at the star J1407 right now, and here's its planet J4107b. So if you watch like the TRAPPIST-1 system, you would have known that like all the planets were named letters after the star, because the star represents the letter A usually. But anyways, so we've got JC107b, and I believe this is a brown dwarf, so got it right here. And as you can see, these rings are absolutely humongous. Like, we can put Saturn here to compare as well. So let's quickly do that. So yeah, let's put Saturn right here, and we'll add rings to Saturn, and you'll see the difference. So here's good old Saturn right here. Gotta love Saturn, planet with the best rings in our solar system. But these Saturn's rings are no match for this planet's here's rings, or this brown dwarf, or whatever you want to call it. But anyway, so let's add its rings in. So there we go, right there. Okay, so there's Saturn and its rings. But if we zoom out, you can see that Saturn's rings are just absolutely inferior compared to this planet's here's rings, which is absolutely crazy. And if you didn't know, this ring system is 60% the size of the Earth's orbit from the Sun. So obviously one distance from the Sun is, or one orbit, one Earth from the Sun is called one astronomical unit. That's pronounced that correctly. And this ring system is 60%, so 0.6% the size of an astronomical unit. So if we go out to, where's one about? Okay, so this is one there. So imagine this was the Sun here. So imagine that was the Sun, and the Earth would be right here normally. Look how large the rings expand out. Like, we can actually add it to the Sun actually. So if we go to let's just go to the good old solar system quickly. So let's go to my custom one here, since I like this one more. Right, so let's zoom in right here, and then hit add. Then we're going to go to rings. Let's just do Saturn's rings. And instead of being Saturn's rings scale here, let's go to AU, and then AU again. So let's do it from, we'll just leave that like, actually, oh no, we don't even need this as AU actually. Let's just have it as 100,000 kilometers, because that's not really a big deal. And then we want to go to 0.6 AU. So we add those in. This is the ring size of that planet, and if we could just click it again and make it a little stronger, as you can see, that's 60% the size of the Earth's orbit here. So the massive rings with Earth compared, like, these rings are literally, look, they're over half the size of the Earth's orbit here, which is absolutely crazy. And if we load the simulation up again, so we'll literally delete those. Wait, can we delete them? Okay, we can't for some reason. The key, oh no, we did delete them, it just took a while. Alright, so if we add these rings to Saturn, then we look at the sky from Earth, you'll be pretty impressed with this. Like, this is pretty crazy. So let's quickly go in here, let's add these rings. So right here, let's go to AU again, and then do 0.6, because that's how large they are. Yeah, we actually discovered this star a long time ago, or not the star, we actually discovered this planet with these rings a long time ago, and honestly, I don't think we know for sure why these rings are so large, but I think, I'm pretty sure we think they are this large because they, this planet system, like the J4107 or whatever it was called, that planet system is quite new. Like, it was formed more recently. Like, it's definitely a lot younger than our solar system, we think. So it could just be a planetary disk of like new planets which are still forming. So basically, it could be a solar system that's still forming or in progress of forming. So yeah, that's pretty interesting if you ask me. But anyways, let's go back to Earth. Let's remove that, and as you can see, having that in the night sky would be so cool. So there's the Sun there, there's the Milky Way. Now if we land, let's land just off the coast of Africa here in the ocean. Alright, and then let's look up the night sky. So you can see the Sun's there, so we're basically sunset, so now we're in the night time. If we look up, look at that. That is absolutely crazy. Like, that's like a galaxy almost. Like, the size of that is literally insane. But anyways, let's go out of Earth again, and we'll quickly view these rings again. Yeah, this is more a more short video than usual as well, because honestly, there's not much we know about J4107b, so let's quickly go back to it. We don't really know much about it, so I can't really say much about it, but if we were to play out this simulation here, these rings would probably break apart, because I'm pretty sure the star would pull some of the material away. But honestly, how did a planet form like this around a star? How come, you'd think, if it was a forming, like, solar system, why isn't the dust ring cloud around the star instead? Well, I'm guessing that this planet must have picked off the remaining pieces, or whatever's going to form in this, because obviously something will probably form, like a moon or something. This is probably where all its moons will probably form. They probably won't be that far out, but honestly, I have no idea. But anyways, let's speed up time, if we even can. Can we? Next, you can see the rings are moving. Look at that. I mean, this is literally so cool. Like, if we look at the planet, just look at these rings. Look at all those little particles. Like, every single one of these has their own physics, and then every single object with physics makes the game slower. And look how many there is here. I'm pretty sure my computer is quite a good beast for actually being able to handle this, but look at this. As you can see, the rings are getting bent, because if you look, the star is here. Like, that's getting pulled by the star. Honestly, I don't know if this simulation is entirely accurate, because I don't know how far the planet is from the star, but this is what I've had for a long time, so I'm just going to live with that. But anyways, this is literally crazy, but this could maybe actually happen to the actual planet with the largest rings. It may eventually just get torn away like this by the star, or eventually it will just become moons or planets. Like, that's pretty much it. Like, there's not really much else you can do. Oh my gosh, look at this. It looks really cool though. Alright, let's quickly load up a whole new simulation actually. Let's call in the planet. So, what's it? I can't remember. I think I have it in my can never remember that one. Yeah, J1047b. So there we go. Here's the planet. It turns straight into a brown dwarf star as well. And let's add the rings on. Let's see what happens if we launch an Earth into these rings. Right, let's get Saturn. Let's go to the advanced settings. Let's go to 0.6 AU again. So there we go, like that. Let's add the rings in, and as you can see, there we go. Let's add them a few times. Not too many though. Alright, so here we go. So all these rings are not going to get affected. But what happens if we shoot? Now I think Earth may be a little too small. Let's shoot Jupiter. Oh, I guess we can shoot an Earth. We'll just shoot an Earth at the other side. So let's shoot Jupiter right in to the planet here. So let's get it, launch it, and press. So now Jupiter's going to invade, and then we'll do Earth as well. So there we go, like that. And now Earth is on the collision course. So let's zoom out again. And now, here's the good stuff. So let's see what happens when Jupiter comes into contact with the ring system here. Well, what happened? Why is Jupiter moving like it's going away? What? Why is it doing that? Is this planet like completely like, is it got a force field? Why do the planets just bounce off like that? Well, that kind of sucks. Alright, I am back. Got rid of that problem now, hopefully. So Jupiter has already entered the rings. So if we quickly zoom out again, Jupiter is right here right now. So it's entered the rings. Now it's hit play. And as you can see, it is bouncing all of the rings out of place. So you can see they're getting launched upwards here. Look at this. This is crazy. In fact, let's go even more. Let's add even more rings to the planet and see what happens. This is going to be absolutely insane. And Earth is also back as well. Don't know if you can see it right now because it's quite small, remember. So let's do that. Let's add the ring a few more times like that. So that's going to be pretty cool. Yeah, Earth is over here right now. So let's quickly hit play. And the lag has increased, but I think it's worth it, honestly. You can see that this is crazy. Look at all of like the damage it's causing to the rings. They're all getting, all these little particles getting slung apart. But as we get closer and closer to the main planet in the middle itself, this is where stuff's going to get pretty cool. And imagine putting a planet in here like Earth. Like, Earth would get hit by all of these rocks and stuff. Like, Earth would probably get eliminated pretty quickly. Or all life on Earth would get knocked out, I mean. Alright, anyways. So is it going to collide with the planet or not? It looks like it is going to, but look at all of the terror it's causing. Look at all these objects. And Jupiter is very dead now. But it did knock this thing out of place. Look, it's now spinning everywhere. That's pretty cool. Look at all the damage it caused. Look at that. That is crazy. It's like I don't even know how to describe that. It's literally like something's like smashed right in the middle and all these parts that came out. Right, here's Earth now. Let's see what's happening to Earth. Yeah, as you can see, Earth isn't really doing anything at all, because poor little Earth isn't big enough. So as we can see now, we're going to throw is Earth going to hit it? Yeah, Earth's... Oh no, Earth survived. Wow. And it's gone now. Alright, actually, let's ramp up the things a little more. Oh, did Earth cause that? Actually, it looks like Earth caused this bit. Like, you actually see there's a little, like, gap here. I think Earth actually just caused that. But anyways, let's take it up even more to a high level. Let's add the sun in. and see what happens here. This isn't a good idea, I can already tell, but let's do it anyway. So let's launch, and the sun is on its way to destroy this ring system completely now, hopefully, because it's going to destroy this planet here. This planet's not large enough, or brown dwarf, whatever you want to say. Oh, look at the sun. The sun has just got so much weight in it, or so much mass, it's pulling the rings apart, and it's pulling the sun isn't even coming towards it, it's pulling the planet towards it now. Look at this. This is crazy. Now it's just the sun is literally stealing all of the material now. Still don't know why the sun's going there. Let's just quickly pull it on 0 velocity, so it will go back. So it's that. Okay, now it's heading straight towards the planet on a collision course. So, as you can see, this ring system is very delicate. See, any object, even Jupiter, could literally ruin this ring system. So, I have absolutely no idea how this ring system ever came to be in real life anyway. But, as you can see, the rings are about to literally just get slung apart. Look at all of the material which is getting thrown away here. This is ridiculous. This is really fun though. I've never actually tried this. I think I said that in lots of videos, but literally I've never ever shot the sun into this planet before. I only made the simulation and never really went on it again, but oh my gosh, this is crazy. Look at this. It's literally like the ring system no longer exists. Alright, anyways, yeah, make sure you hit the sub button for more epic things like this, and if you have any recommendations for another video, please leave a comment down below. But this is pretty awesome. Yeah, if you've got any more like things I should do with the planet with the largest rings, turning planets into a star, I still haven't finished that like series off. I'm planning to do it again soon. But as you can see, this is insane. So look at it, the sun has literally stolen it, and the planets, I'm guessing, is getting ejected out now, maybe? I don't even know. But anyways, that will end it off, so let's get out of this laggy simulation, because the ring system pretty much no longer exists. It's just the sun with a bunch of debris around it. But anyways, now we can just look at the pretty old Milky Way in the sky here, I guess. But anyways, like I said, hopefully you all enjoyed this video, and make sure you leave a like, subscribe if you're new, leave a comment, like I said, for another video if you have any ideas. And yeah, I'll see you in the next video. Goodbye. You'll see the difference. So here's good old Saturn right here. Gotta love Saturn, planet with the best rings in our solar system. But these Saturn's rings are no match for this planet's here's rings, or this brown dwarf, or whatever you want to call it. But anyway, so let's add its rings in. So there we go, right there. Okay, so there's Saturn and its rings. But if we zoom out, you can see that Saturn's rings are can just absolutely. Hello everyone, and welcome back to another Universe Sandbox 2 video. Today we are going to be looking at the planet with the largest rings ever discovered. So this planet was discovered quite a while ago now actually, but anyways, I made a simulation quite a long time ago of it. This is probably when I first actually got the game, and there's some people would have known that like all the planets were named letters after the star, because the star represents the letter A usually. But anyways, so we've got JC107b, and I believe this is a brown dwarf, so got it right here. And as you can see, these rings are absolutely humongous. Like, we can put Saturn here to compare as well. So let's quickly do that. So yeah, let's put Saturn right here, and we'll add rings to Saturn. And it takes a while to load, because once you see these rings, you can't actually see them yet, but once you see these rings, you'll know why this simulation is going to be very, very laggy and slow. So let's turn the time down, and now voila. So as you can see here, those rings are absolutely huge. So we're at the star J1407 right now, and here's its planet J4107b. So if you watch like the TRAPPIST-1 system, inferior compared to this planet's here's rings, which is absolutely crazy. And if you didn't know, this ring system is 60% the size of the Earth's orbit from the Sun. So obviously one distance from the Sun is one orbit, one Earth from the Sun is called one astronomical unit. That's pronounced that correctly. And this ring system is